Okay? We're going to go over the interior and exterior angles of a triangle. Okay? Now, you guys should be somewhat familiar with the angles, like the words interior and exterior, because we talked about these words before, right? What does interior mean? Inside. What does exterior mean? Outside. Okay? Now, on your note sheet, you should be on the front that says notes, okay? The back of your note sheet is homework, so make sure you're not on the back, okay? And we're going to go through and talk about interior and exterior angles of a triangle, okay? So, the first type of angle that we're going to talk about are the exterior angles, okay? So, exterior angles, label onto your note sheet on the diagram where the exterior and where the interior is, okay? Angle 1 is an exterior angle. Okay, all the other angles are interior angles, which are the angles inside. Now, an exterior angle is an angle that is formed by one side of a triangle and an extension of the other side. Okay, so if we're looking at this, if we were to extend this side right along here, this length BD, okay, and continue that side, then it makes an angle with the other side of the triangle, creating angle 1, okay? Angle 1 is an exterior angle of the triangle, okay? So if you need to, like, circle or draw an arrow or something to angle 1, showing that that is the exterior angle of the triangle, okay? So BC is a side of the triangle, and BA, ray BA, is an extension of the other side, which was BD. And so that creates exterior angle, angle 1. Okay, so write that down, add that into your notes. Okay, and remember, exterior means outside. So when you have an exterior angle, it is the angle that is outside. So it's this angle right here, angle 1. Remember, it's being created by taking this side BD and extending it, okay? And then that creates an angle with another existing side. So it's this angle right here that's being created, okay, right here. This angle, angle 1. Does that make sense to you guys, what an exterior angle is? Okay. All right. Do you guys need more time writing anything down there? Yeah? Okay. Okay. So our next type of angle is called a remote interior angle. Okay. So when you guys think of the word remote, probably you don't think of math or geometry when you hear that word. You probably most of you probably associate the word remote with the TV, right? Like the remote control, okay? What are we doing? Why do we use a remote control? Yeah, to change the channel, but couldn't you like walk up to the TV and change the channel from the actual TV? Yeah, you're all too lazy, right? So you use the remote control so you can be like far away from the TV, right? But still change the channel, okay? So that word remote, okay, means from far away, like from afar, right? So far away, okay? So the remote interior angles, okay, are going to be inside the triangle, and they are the interior angles of a triangle. Not adjacent. Remember, adjacent means touching. So not touching the exterior angle. Okay, so I want you guys to look at the exterior angle. The exterior angle is angle 1. Okay. Now, they're the interior angles that are not touching it. So that would be like angle C and angle D. Those are the ones that are far away, not touching the exterior angle. Okay, so you have your exterior angle right here, angle 1, right? This was your exterior angle right here. So the remote interior ones are the ones farthest away. So if I look at B Angle B is the closest angle, right? So that's not considered remote. Remote means far away from the exterior angles, so that would be like this one here, and then this one over here. Does that make sense? Those are your remote interior angles. So in this diagram, it would be angle C and angle D. These two angles are your remote interior angles. Okay? They're still going to be inside the triangle. They're just far away from the exterior angle. Okay? All right. Do you guys need a moment to write some of those things down? Yeah. Okay. So now let's talk about the exterior angle theorem. Okay? So here's what the exterior angle theorem says. It says that the measure of an exterior angle of a triangle is equal to the sum. What does the word sum mean? The total for adding, right? Okay, the sum of the measures of the remote interior angles. Now, I know this is kind of like wordy and can be confusing at first, but this is all that it means, okay? It means that if I take this exterior angle that I have right here, this one adds up to be the same amount as the two remote interior ones, which were, remember, remote interior ones were these ones over here, this one, and then this one, right? Okay, so all it's saying is angle 1 adds up to the same amount as these two put together, C and D, because they're the remote interior ones, okay? Now, why does this happen? Okay, this always happens. It's always true for any triangle, okay? Here's why it happens. How much do the three inside angles, the three inside add up to always? 180, right? How much does a straight line add up to always? 180, right? So you know that whatever this measure is right here, right? That one, whatever that is, adds up with these two to make 180, right? You also know that it forms a straight line with that exterior angle, so it's going to add with that one to make 180, right? Therefore, in order to add with these two to make 180, and to also add with this one right here to make 180, it has to be the same number. This one has to be the same number whether it's adding with these or whether it's adding with this. Do you guys agree with that? Okay. So therefore, if we subtract from 180, whatever this is, right, that'll give us that number. When we subtract from 180, it'll also give us the total here, right, which is going to be the same number. Are you guys kind of following what I'm saying with that? Yeah or no? Okay. All right. So let me just give you like a number example. Say this angle right here, this one was 20 degrees. Let's just pretend. Okay. What do you know that angle 1 has to be to make that whole thing 180? That one has to be 160, right? Now you also know that these ones over here are all going to add up to 180, right? So what do these two have to total up to? They also have to be 160. Let's try to squeeze that in there. All right? Does that kind of make sense? Why angle 1 ends up being the same as angle C and D put together. Are we kind of following that? Does that make a little more sense now? Okay? All right. Okay, so this is the exterior angle theorem. Now, today we can actually use the exterior angle theorem to help us find some missing angles. Okay, so that's what we're going to be doing in our notes examples today. Okay, does anyone need more time writing anything that's up there? No? Okay. All right, so let's take a look at doing some examples together. Okay? So what I want you guys to do is on the bottom half of your note sheet, there's actually some examples that we're going to do. Get out a pen, pencil, highlighter, whatever you need, so that we can do those examples together. All right. Okay. Let me zoom in a little so you guys can see. Okay. So on this one, it says find the measure of the indicated angle. Okay. So we want to look at which one is the remote. We want to look at which one is the exterior angle and which ones are the remote interior angles. Okay. So the exterior angle, remember, is always outside of the triangle. So when I look at the triangle, I see this angle right here. This is the exterior angle. That one is outside. Do you guys agree with me on that? Okay. Now, when I'm looking for the remote interior angles, okay, I'm going to look for the ones that are not touching that one. Okay, so I see angle A is sharing a vertex with that exterior angle. So angle A is going to not be remote. Okay, what are the other two angles in the triangle? C and B. So that would be this one here and then this one here, right? These two are going to be considered your remote interior angles because they are not sharing a vertex with A. Okay? Now, the theorem we learned said that these two add up to make the outside one, right? So let's call this one, since we don't know it, let's call it X. So X plus 35 equals 55. Okay? So now, solve that. So what do we get? X equals 20. Okay? So now, it was asking, find the measure of the indicated angle. That was this angle. So the measure of angle C is going to be how many degrees? 20 degrees, right? Okay? Does that make sense what we did there? We added up the two remote exterior or remote interior angles to equal the exterior angle. Okay? All right. Let's take a look at number 2. Okay, number 2 says solve for X. Okay, so let's take a look at where your exterior angle is. Okay, let's highlight it. Okay, which angle is your exterior angle? What is its vertex? What letter? Q, right? So it's this angle right here. This one. Okay, so that's your exterior angle. Now, which ones are your two remote interior angles? Well, they can't have the vertex Q because Q is going with the exterior angle, so they have to be not touching that vertex. So which vertices are we talking about here? Angle S and what else? R. Angle R, okay? All right, so now, what equation are we going to set up? Okay, 13x minus 7 plus 60, so we're adding up these two, equals how much? 20x plus 4, right? So the two remote interiors add up to make the exterior, okay? So now let's go ahead and solve this. Okay, I'll combine my like terms here. Okay, I'm going to move the 13x over. Okay, I'll subtract 4. Okay, what do I get for my value of x? 7. Okay, now, did I answer the question? What did the question say? Yeah, so I'm done, right? Okay. All right, so are there any questions about what I did there on that one? Okay. Okay, so let's take a look at problem number 3. Okay, number 3, it wants you to solve for x, okay? So first, locate your exterior angle. What is the vertex for your exterior angle? E, okay? So it's this angle right here created on the outside with the vertex E. Okay, now, look at your interior angles. They cannot have the same vertex. So what other two letters do I have there? C and D, right? So it's going to be this angle here and then this angle here. Okay? So what am I going to go ahead and add together?
7x minus 2 plus 10x plus 9 equals 127.
Okay, good. So these two add together to equal this one. That one is 127. Okay? So now let's go ahead and solve that. Okay, I'll put together my like terms. And then I'll put together these other ones. Don't forget, this is a -2. A lot of you guys have been making these silly mistakes on your quizzes and your tests where when you have this and this, you tell me it's 12. This is like a -2 plus 10. What's a -2 plus 10? 8. Okay? A lot of, when I graded your test, silly mistakes on little things like that. Okay? All right, so now let's go ahead and solve this. So we're going to subtract. Does that make 119?
Yeah.
Okay. Did anyone divide yet? Okay, what'd you guys get? 7? Okay. All right. Now, have I answered the question?
Yes.
Yeah, so this is your final answer. Okay. All right, let's go to the last one. What is the question asking us on the last one? Does it say solve for x? What is, okay, it wants us to find the measure of an angle. So we're still going to do the same whole process in our setup, but then at the end, I'm going to plug it back in to make sure I find that angle that they want. Okay? So let's go ahead and highlight your exterior angle. Okay? What is the vertex of your exterior angle? D. So it's this angle right here, right? Okay, now we can't use D for our remote interior angles because they can't share the same vertex. So what are they? Angle B right here and angle C right here. Okay, so now let's add together which ones? Plus 44, right, is equal to the exterior. Okay, so let's go ahead and solve that. Are you going to write down 49 right here? No. What kind of 5 is this? Negative. So what are we going to write down? 39. Okay, for me, I would probably move the 15x, but you can do it however you want. Okay, so what do you guys get for your value of x there? 6, right? Now, have I answered the question yet? No. Okay, so I need to figure out which angle is angle UDC. Well, what is the vertex? D. Okay, let's make sure, just by tracing it over, UDC, C. So is that this angle right here? Yes. Okay. So I'm going to plug into this one. Okay, so the measure of angle UDC is going to be 22 times 6 minus 3. So what is 22 times 6? 132. Okay, and what is 132 minus 3? 129, right? Okay, and that's the number of degrees. Okay, now have I answered the question? Yes. Okay. All right, are there any questions on that last one?